All right, yeah, hey everybody. Hey, all five of you. Okay, so contributing to NgRx with the component store. Let's go over some of the plans that we have for today, and why I'm actually starting all of this. So what I wanted to do is to give a little bit of example of how to contribute with the fairly larger features. Hey, Bram. Fairly larger features to large repos, and how, as a maintainer of one of them, I see those PRs coming in, and basically, a great people have great ideas, but sometimes it's hard to just merge that in and or basically review thousands and thousands lines of code. So I think I wanted to have some kind of a better example of how to do this. And not that I contribute to open source a ton. NgRx is one of the few projects that I actually contribute somewhat actively. But I wanted to show, at least this is also the process that we kind of follow within Google as well, right? We have features, we break them apart, how we get the PRs in, and stuff like that. All right, so let's see what's happening. Okay. Share the screen as well. 1, 2, 3. Okay. So generally, we would have a following process, right? Like when we're coming up or having a new library feature, such as ComponentStore. The first thing to do is, the feature has to be discussed with the team. Does it make sense? Does it, what it's going to do? What is the problem we're trying to solve? And this is where, just sending a PR right away, even if it could be a small feature, right? Just sending a PR with a substantial size can be very confusing. Very confusing. What are you trying to achieve? Even if you have a lot of description in there, this is going to do this, and this, and all of that. You already put a lot of effort into it. You've written your code and all of that. So the best way to actually do it is first, just write a small design doc or a larger one, and specify what exactly you're trying to achieve. For example, this is what we did with the component store as well. So this is, I'll post the link. It's basically, oops. I'm sure you've probably already seen this. And we're not going to go over this in details, but just going with the example. All right. So we start with the design doc, and the first thing we do is we have like an objective, what we're trying to achieve with this feature over this library. And then there are different multiple templates for design docs. This is fairly detailed. We are seeking some of what we have, what the expected developer experience would be, trying to highlight them, some of the stories that can relate to, and further some of the background, how things were solved before, were there any attempts to solve this problem, how else is being solved. And some of the goals and no goals are great for this. Then some prototype. But basically, we can go, it goes further and further. Here, it was a little bit more detailed. We go into the APIs already after a certain point, and further and further into the details. Some minimal design, and then some of the detailed design. And one of the most important part is to have comments here. It's really important because when you're trying to show this idea, you really want people to understand what's underneath it. How does it work? What's it for? So having a design doc is really great approach for any, even a smaller feature. This is where you are asking everybody to provide the input, their thoughts on this, if it makes sense or not. Because when you're already sending a PR, that is not the time to discuss the design. And fairly frequently, if this is the time where design discussion starts, it could be very frustrating for both maintainers and the person and contributors, right? So that's the approach that I took with the component store as well. And by the way, component store is not my idea as well. My teammate from Firebase, Kevin Yelko, created original version of it, and it seems to be solving the problem fairly well. People liked it as well. I looked also in it, and yeah, it's nice for specific use cases and stuff like that. So then we decided to go a little bit further and push it upstream, basically, with further improvements in performance and then also given all the feedback that I received for the component store, we iterated over design and changed things a little bit. Yeah, so that's how basically there's some backstory, and we have it in Firebase, a minimal version of it since fall of last year. So it's been around. Okay, so once we have a design doc, and in this case, a majority of core team looked at it, whoever has time, and then provided additional feedback. And basically, overall, I got approvals from most of the team members. So that means that basically design and general idea is good, and let's start implementing it now. And of course, there's two ways to do it. One way is just, shove one giant PR again. But that's also, it's creating more problems again. Large PRs, I think Sarah Dreisner has an amazing article on that. But it's like, it should be, I guess, common knowledge that, large PRs create a huge burden for reviewers, right? You want to be able to spend, up to 15 minutes most on the PR when you review it. You want to understand it. You want to know the backstory of it already. You want to see the code. Does it make sense? Does it not make sense? Are there any stylistic things, or hey, you overlooked the here and here? So that's another thing with the small PRs. Sometimes PRs could get large, and mostly they can get large because of the tests. And that's another thing. Tests should accompany any PR. Unit tests should accompany any PR. And I'll submit a test later is not what we're trying to achieve. Basically, anything in the master should be complete, should never be broken, and should be tested. Integration tests and end-to-end tests, those could be added a bit later. That's fine to add them a little bit later. But the unit tests, you basically prove to yourself first and to maintainer that the code that you're submitting actually works. Okay. So that's the goal then, right? Well, once we have the design approved and the feature is generally accepted, break it apart into the smaller PRs that have tests accompanying that. Tests, one thing we're asking docs to be accompanying the test, the PRs. doc changes. That could be also put a little bit further if you have like a whole series of PRs ready to go. But yeah, it's also good practice to add at least some documentation. By the way, when you're writing tests and documentation, you go back to your implementation and start questioning it. Like, does it make sense, right? Do I need to change it a little bit? Do I need to change actually more? All right. And I mean, this is not the exception. When I was writing unit tests for the first iteration for the PR that we're going to see soon, I also was, asking, okay, so what do I do? Do I need to do it or not? Actually, let's try to do it this way. I'll do the code. So my code here. And I'll push this guy here as well. So I'll do the split screen. Oops. That's the entire screen. I did it again. Okay. All right. Let's do this. It goes left side. This one goes right side. And we'll shrink it down a little bit. Okay. Hopefully that's all right. Whoever's watching, do you see the code clearly, or should I bump up the size a little bit? Looks. Yes, it's somewhat readable, right? Yeah. Okay. Leave that. That would be probably too much. Maybe it's okay. Okay. Just in case. Just in case. Okay. So let's see what we have already. NgRx. I'll do it again. Platform. So the design was there, and the basic demos and stuff like that, it was all there, even with observables. I did another overview of it. It was like a 3-hour overview of what it would be capable of doing. Some feedback that I got was that we didn't quite address what problem it solves. I think that deserves a whole separate topic that we won't be dedicating time for it today, but it's definitely a great thing to discuss what exactly it's trying to solve. All right, close this. So the original implementation was there for whatever it was for demos, right? So it's basically almost like a proof of concept. Basically close it. And it was there. It was great. It was working. All right. So now let's see what we have in NgRx now. Nothing is submitted there yet. The only thing that we do have there is, let's look at it. So modules. This is where we keep all our libraries. As you can see, entity store is here, component, and ComponentStore is here. So it was added 4 days ago. But what was added the initial setup. So it's empty. It's all the, boilerplate. Nothing in here, index, just like placeholder. Oops. Yeah, Dr. Trees coming up. Nothing in there. Don't have anything. Basically, it's just some scaffolding. Okay, awesome. So NgRx component here consists of three major things. First thing is the APIs, how we update the state, how we set the state. We settled on the name of a function to be updater. Seems people like it. And we will also have setState. And again, the API has changed slightly with this implementation. So we'll see how that goes. All right, so we have updater that updates the state in the component store. And a component store, basically is like a service with a subject that is attached to a particular component, and it's attached to its life cycle. What's great about it, component gets destroyed, the entire state is gone. And then another great feature of that is if I have multiple instances of the same component, each one would have their own independent kind of store, component store. And the other good thing, I guess, is that the library itself is not it's not attached to NgRx, the global store, in any way. And also, at the moment, I might not have any Angular dependencies as well. So you can, in theory, use it anywhere you want. Okay. So the API itself, since we're submitting the code, and it consists of three major components. First one is this updater itself. And this is the way we set the values into the store, right? We have like an updater function that takes like the previous state, a new value, and basically you can push that new value into the state. And this updater actually gives you a function back, right? Like this add value. And you can use that function or that method and pass those new values into it every time from different places, basically reusing this updater. Second one is a selector. So updater is updating the state, selector is selecting the state back, okay? And effect itself. So this is the way to run some of the side effects within your component. And this is a great way to do it there through the effect. It's very nice. This is such an important part of the component store that you can imperatively pass the values into it, into the effect. And they are all basically piped into a specific observable, right? Like this one, for example, here. There's IDs, right? I can imperatively call the set IDs wherever I want to. And this is frequently done in the component when you basically attach it to the callback of a function, right? You call a function, it's imperative, the callback, you set the ID, you basically push it into this effect. And this effect now transforms all of those IDs that you manually pushed imperatively into a stream. And you can really control how that, you can really control that stream and how you're flattening all these incoming values, right? The observables that create like concat map, switch map, exhaust map, merge map, all that. This ability is super important. Yeah, the only dependency would be NgRx. Yes, that's pretty cool. Let me see. I see. Okay, great. Yeah, so this is super nice. And for me, this is a very important feature. So this is basically three things that it can do. And the whole thing then revolves around those three things. Okay, but we won't be jamming all of those three things at once to a reviewer and asking, hey, please review all of this. Usually Tim or or Brendan review the code for me. Sometimes other people as well. It's always nice, I guess, when somebody reviews it, as long as they have some context around it. Yeah, that's great. So we won't be throwing out everything at once at them, especially since we are iterating over and over, and our implementation is already a little bit different than what we have in the design doc and some of the demos. Okay, great. So we got that out of the way. So the first thing we'll do is submit this updater part. But it's not just updater itself, because when we create this component store, we need to initialize it. And through some of the feedback in the community, there was a suggestion to, hey, right now we are initially initializing the component store through the constructor, right? So we got the default state or the initial state, and we were using the behavior subject underneath. And I mean, it works great. It works great. But what if you don't have the initial state yet, right? What if you're selecting from this component store as well, and you don't want to have this initial state, which is could be the value now they're interested in. I don't think I had those problems a lot, but I mean, if we can do it other way, maybe why not? And this is what we end up implementing. We also implement the lazy state. All right. So let's see the structure of our component here. So I already started implementing it. Actually, almost implemented it. So what I have is the component store. Okay. And then in the sources, again, this was the index. The only thing that I had, was for placeholder. Now we have an import from the component store. Okay, and then we will have our component store implementation itself. Oops. There we go. And we don't need that for now. So the first thing what we do, and again, it's growing, but it's only working with a few things right now. Okay, so for the first thing is we have our component store, right? And we set up the type here. This is the type that the whole thing would be working with. So it sets the type for the entire component store. This is the state, the interface that we'll be working with, and the state that will contain. So one of the things you might notice right away, the difference here, instead of using the behavior subject, right, which requires the initial state because it always has this default state, behavior subject, we'll use the replace subject instead, and we would use it with a 1. So 1 means it will replay only one last value when somebody subscribes, because when somebody subscribes to things, they want to have some kind of value back. But we also can have no values yet. All right. So we will use the state subject, okay? And for now, we have this get state function here, and state actually as well. We initialize it through create selector. Right now, we don't have a selector, right? So we will just have that state subject that we have exposed as observable. And this is the top level, basically state, the entire state of your component. Of the component store, the entire thing. So it's observable of T. We would also have this initialized Boolean, and we set it to false right away. Okay. Let's look at some other properties. So we also have this destroy subject. And this is the subject that cleans up and will later be needed. I don't think we use it yet. Yeah, we don't use it yet. We don't use it yet. But this is how we would, well, we kind of use it, but don't we destroy it in our NgOnDestroy thing? Okay, so we have it there. And it should be used only in NgOnDestroy, by the way, right? So this is the subject that takes the value when it should be destroyed. A lot of things in our component store, we would use this destroy observable, and they would use it in combination with take until. So everything would be running until this destroy signal is sent. This is exactly how we would know that component, got destroyed, and this is exactly how it's attached to the life cycle of the component through this NgOnDestroy that sets the entire destruction thing, and everything that takes until this destroy, take until is RxJS operator. Then it'll all be cleaned up. Any observable will start emitting things, will also be unsubscribed. Okay. So this is why we have them here. This one is private read-only because it's a subject. We don't want anything outside of this component store to have control over it. So that's why it's private read-only. Read-only also means that nobody can reassign this value because we don't want by accident or on purpose reassign it. But then Google will have like a TypeScript style guide, which says always mark things read-only that you intend to be read-only, right? You then never plan to assign outside of the constructor or here, yeah. So make it read-only and make it private, okay. And destroy is read-only, but it is exposed to anything, to any component that uses the component store. And now that's a kind of a neat little feature that means that to have this, replace subject with a destruction, like this one actually, destroy subject, and and have this on NgOnDestroy for your component, and setting all of this up, it's like a very common practice, right? There's one way is subscription, and you add things to the subscription object. Yes, that's one way to do it. The other is fairly popular practice is to have this take until, but you have to have your internal, destroy subject, and then you basically have your NgOnDestroy, and all of this you have to do yourself. Right now, you can just attach any observables within the component that are running with take until to this destroy exposed by the component store, because it's basically attached to the same life cycle of the component. So it kind of saves you a little bit of code that you have to write in the component store for this destruction. All right, so that's why it's exposed. That's why it's not private. So I'll have this read only. Okay, and now the constructor. So constructor before was taking the default state. Now it will take it optionally, right? So the question mark, optionally. And if it does take it, if it's passed in here, we'll just call this initState method here. Okay, so that was the constructor on NgOnDestroy. It's clear. By the way, we're not extending this. I'll actually not implementing the NgOnDestroy interface. That's coming from Angular. For one reason only. Angular doesn't really need this interface. All Angular is looking for this NgOnDestroy method to be there. So it's literally looking for this because, again, Angular is running runtime. Runtime doesn't know about interfaces. Interfaces is TypeScript thing, and they're obviously all gone when TypeScript compiler goes over the code. So Angular needs to know that it has these NgOnDestroy So it's looking for basically that thing, NgRx that thing. What we can create is we can create the interface that's not really attached to the Angular framework, like a similar NgRx, but our own. We can do that too, just to make sure that NgRx is there, but it's not quite necessary. And this was the only thing that was attached to the Angular itself, right? So that's why I was bringing this Angular dependency, and got a few requests saying, "Hey, can we make it framework, almost framework agnostic?" Sure, we can. We can, and this is what we do. The only the only thing, of course, it would be very easy to work with Angular. If you're working outside of the Angular, you would have to call this ng on destroy yourself. So that's maybe a minor thing, but it could be used outside of Angular. Okay, and then so we have this init state. And what does the init state do? Let's find this. So init state basically marks that it is initialized state now, true, and it pushes that state that was passed into to our state subject. So now we would have a value. Notice what's important here. We cannot push like partial state, and we don't want to push partial state. We really want to help, for TypeScript to help us. So T is what our ComponentStore works with. So we don't want to partially initialize the state. If you're choosing to do lazy initialization later on, that's fine, but please provide the entire state, right? So we can rely, our selectors can rely that it's actually following everything. So it's still very, very type safe. Okay. So, but we could do lazy or deferred initialization. Yeah, Santosh here as well. Hey, Santosh. Man, it's probably like what, early morning for you now? Wow. Okay. So we have this init state that just pushes this value to the state subject. All right. Right next to it, you'll see another function. And that function is called setState. And, unlike the init state that just takes this this object, right? setState can take both the object of this type T, which is our ComponentStore type, or it can take the callback here, right? Given some state, give us the value. And what's interesting, we can actually initialize our state with the setState itself as well. So if you pass just an object to the setState, see, this is what we check here. If it's not a function, right? Because this would be the function. If it's not a function, we'll just init the state. And it doesn't matter that the state could be already initialized a number of times. That's fine as well. Why did I do it here? Why did I do it this way that you can basically initialize the state through the setState itself? Well, imagine you have an input on your component, and you want your state to be initialized before the first input arrives, right? And you put the setter on the input, and within that setter, I think I have the example somewhere here, like this. Well, it's not lazy, but no, I don't have it here. I have it in my other one. Let's see my stack. Basically, now in my input setter, I can just do the set state, right? And the first time it will initialize the state, but the next time it will just, push this new value into the state. This is lazy init. I don't think that was working. Editor. And let's see the code. That's compiling. It's a lot of, okay, yeah. I think it's something here. Yeah, oh, almost like this. Yeah, basically like setter like this for the ID. For example, if this is how I want to get, like this is actually the effect, and this is a valid case as well, right? So we can basically set state that way. And so I don't want to do, was it initialized? Especially I'm not exposing it if it was initialized or not, right? This is private property. So we're not exposing if it's initialized or not yet. And there are ways you can hold your observables until it's initialized. That's another cool thing we'll see today. All right. But I would basically setting the state, and if you pass just the object, it'll call this initial state anyway. If you are passing the function though, it will call this updater. And updater is the main part that was discussed, and this is one of the very important parts of the API. This is how we set the state based on the previous state and new values. And one thing that you might notice here is, updater takes updater. Here's updater. Updater takes this updater function, which can take a state and a value, and it has to return this new state, right? And I'm passing the function here, right? So we check that this is either an object or a function, and we just checked, okay, this is not an object, not a function, so which is in its state. So why do we need to cast here? Why do we need this as? That was actually interesting situation for me, because I thought the TypeScript would be automatically able to infer that, hey, I already know that this is not T, so it must be this, right? Because I'm passing the OR here, or this is the type union. And it kind of knows that T is here, is a function. But because T is an object, and functions are also an object, basically I would have to put some kind of guard here to really differentiate between these two. I think the guard here would be an overkill, the type guard, the overkill. So I just went with this as. All right. So this is, I found this interesting. Hey, look. Okay. So this is, we have the init state function, we have the setState function, right? And they both can initialize the state. And the constructor can initialize the state as well if you pass something to it. All right, so let's look at the updater function itself, which could be the most interesting part of it. All right, so this updater function takes a state and it takes a value, and it returns T, right? So it has to return the object of the same type. And now here's some of the TypeScript magic here. We'll get back to that magic in a second. But when it returns this this function, well, it returns this, right? But we'll just get back to this in a second. It returns a function, a callback, right? It returns a function back. And that function can take either a value or an observable. And let's see some of the examples of this. Basically bookstore. Right? Yes, here we go. Sorry. Don't crash. Hey, my staglets is not running. Staglets, what happened to you? It's not happy. It's not happy. I'll close that one. Staglets. All right, I'll reload it. It's not happy. Editor, there we go. All right, so here's our, like update title updater. Oh, yes. So this is, for example, update title updater. First, this is the update function itself, right? So it can take the state and the value, and the value could be anything you want. And then it has to return this new object, right? That has to still be of the same type as this book state, for example. So this is the updater, right? And now this is a function, and we use this function. We use it in the book itself, book component itself. All right, so here it is, right? When we do the update title, we pass those values into. So this is why it returns you that function back. And that function, this is the one, right? Can take observable or a value. So right now we've seen how it takes the value. Let's see how it can take observable. Here's another one. So here's updater that knows how to take a new author, right? And it still keeps track of that book state. So it knows how to update that. But now here, it's called right away with author name observable. Loading. It's not very snappy today. Anyhow, you can probably tell by the $sign that it's observable. So it can take both, right? And will handle both. Moreover, it returns back a subscription. That's an interesting one. Why does it take a subscription? We'll have a test case for it as well, but it needs, given the subscription back, we can actually unsubscribe sooner than our component is destroyed. Say, for example, I'm no longer interested in these names. I can easily take as a subscription here, and at any point in time, I can unsubscribe. There you go. Right, and now I'll stop listening for these new names. I'm not killing this updater because other things could be using this updater, but I'm basically stopping listening for this this observable. All right, so that's why it returns that subscription back. All right, so then we have something called initialization error. So what I chose to do is when somebody tries to Yeah, shakes pistons like this. Exactly. Yes. Well, when somebody tries to initialize to use the updater before the state was initialized, I want to throw in a synchronous way. I want to throw an error because updater relies on the previous state, right? The book state, while we might not have that state at all. So we don't want to by accident almost rely on it, and then something uh, you know something that happens within this function, your state is not there, and basically the whole thing will collapse. So if possible, I'm trying to throw the error at runtime. Okay. Let's see. So first I check, okay, is this observable that I got? Because it could be a value, or it could be an observable. So I'm checking if it's an observable itself. If it's an observable, great, we already have our observable. If it's just a value, then we'll wrap it with an off. Off returns you an observable, and this is a synchronous observable. It's a one-time value. And now we can deal with it regardless if we got observable or not, in the same manner. All right, so now we have our observable, and this is the subscription, by the way, we're preparing. We'll pipe it. We'll concat map here. Why do we do concat map here? Well, we want to see at this point, not sooner, because we want to check. That's a very interesting question just asked. Why are we not checking this is initialized before we even pipe the observable, right? Because sometimes I can set up the observable here, but this observable doesn't emit anything. If it doesn't emit anything, and then state gets initialized, and then it emits something, then it's completely fine. By the time this observable, the name $ emits the value, I already have a state initialized. So I don't want to collapse the whole thing before I know it should be collapsed. Should you always provide an object for a state? Should you always provide an object for a state? Yeah, I mean, that's what I kind of do, unless I'm not understanding the question. All right. Brandon, I'm waiting for clarification there. All right, so at this point, when I already got the value, right? So this observable emitted value, and of course, if we just pass the object here, not an observable, it emits the value right away. It's synchronous, so we get this value right away. So this check will be triggering immediately, and that's also a good thing. So if it's initialized, I'm like, okay, I'll wrap this value with off, and I get latest from whatever the state subject has, right? Because it's already initialized. And this basically gives me the combination of the value and current state. Okay, so this is how I get this. I don't think this could be a number or a string. Let's just try it. I think so. I don't think so. Where's my playground? Where's my playground? Hey, where's my playground? It used to be right there. Oh, here it is. That's very interesting. So they choose to hide the playground if it's a little bit smaller. See that how the playground disappears? Oh, that's the one the most important part there. Okay. All right. Here's the playground. I use the playground quite frequently, and it's very advanced here. This is the stuff that I was complaining about. And basically, like what? No, it doesn't take primitives. Yeah, so it should be good, and strings as well. Okay. So this would be only taking a. Yeah, so it should be fine. I can probably take the function as well, right? Save object is a problem there. Still an object, yeah. So yeah, obviously functions is not a good way of keeping the state, but this should prevent from passing strings and whatever. All right, awesome. So basically, if it's initialized, we have this, right? We'll have this off and we'll pack it. But what if it's not initialized? So here I chose to throw an error right away. And I say, if it's state initialized, we'll just throw an error. And I'm trying to take the constructor name. If you're using ComponentStore directly, you'll just get ComponentStore. But if you wrap it with your other service, which I see happening a lot more, but there could be different use cases. Like here, for example, right? I'm doing the bookstore extends the ComponentStore. That should give me the name of this bookstore. So if I do get the error in the logs, and if I have multiple stores, I will be less worried. I will be easier to identify which one exactly was not initialized. Okay. So now we have those, and I throw the error. This is interesting. So when you throw the error goes into the error channel, right? And okay, just hold that thought for a second. And now we take until. So this is one of the first things where we start this. You start to use this destroy, right? This is the one that we created here, and the one that I was, and it's exposed as well to anybody. So we'll take this whole thing, this updater. We only be updating until destroy. We don't want to have any memory leaks. So, and up until now, it should be safe to do this. All right, and then we subscribe. And subscribe will have two things that we have, right? First is we have this value in the current state that we got. And we basically call this state subject next, right? So we're pushing the next value. But before we push the next value, we need to pass it through this updater function, right? So for example, if it's update title, we basically invoke this function, right, with our values, which is the current state and the value itself. I have to tell TypeScript here a little bit not to yell, because technically value could be undefined, but it can be, right, at this point. Okay, so that's great. Next, and this is how we push the new values updated. But there's more code in here. Let's see what's happening here. So error. Error is interesting. So the error callback here, what I do is I do two things. First of all, in this initialization error, which was, it's outside of observables, outside of anything, it's just in the function, in this function body, I assign this error here, right, that we got. Because throwing error here or anywhere within observable is not pushing it outside. It keeps it within the observables, right? And it pushes it to the error channel. And I also let know any subscriber that I had, right? That, hey, I got the error. Most likely, well, the error is that the state was not initialized before you're starting pushing the values into it with the updater. But this one's interesting because now we are outside of this observable, right? And I'm checking if this initialization error basically got the value. And it all depends. We'll get here a value or not if this whole observable is synchronous or not. It would be synchronous if we just pass the value, right? Because of as a synchronous operator provides the value synchronously, so it executes immediately, right? It's not pushing to the micro or macro ticks. Or if we pass the observable that's also synchronous, we'll get this error immediately, which is awesome, right? So it'd be even easier to debug your errors because you'll see where exactly it was thrown. So if the error is there, just throw the error. Otherwise, just return the subscription. Okay, so that was interesting. Now, I want to compare this to the demo implementation that I had to show something really cool. ComponentStore index. Stackless is really not happy with me today for some reason. Yeah, that one was a fine. All right, let me restart it. Maybe I don't think I'm running there that anything that collapses it somehow. Okay, so this is a component store. This is the updater that we had. And yes, this is the updater that we had. And here, I was trying to type the updater with three things, right? First of all, if it's the updater function that completely ignores the state or uses the state in some way, but it has the value, the value is available to it immediately. You might want to just set this the state at its own will. And I think I have it in the example demo 1 component. Yeah, it's almost like this, right? I'm passing the title here. I'm not doing the state, comma, title, because and calling the whole thing with this title, right? Because I don't do this here because I already have this title here and I'm calling this setState immediately. So I'm trying to avoid that, right? So I'm taking the previous state, but I'm not passing the value in this callback, right? I just have the state and I just want to use this. Okay, that was the, and then this is the setState, right? setState just takes the callback, this updater, and actually it's the one that's important. State, that's the shortcut. Actually, I'll just copy this. This is basically the same thing, right? And even right now here, we can see that it's basically the same thing because we're doing this updater and we're calling it at the end, right? So that's basically the state. The state is a shortcut to this because we're not passing the title, which we could, right? Because basically this would be now complaints that it's not there, and this is the same thing. All right. That's awesome. So that's why. Okay, now to the interface. I'll keep that book one there. Hopefully TypeScript will behave. Stack widths will be better. What are we doing? Okay, it's working. Okay, so this is what I was trying to represent. Hey, we can take the callback function with a state, just a state, or we can take with the state and the value, and the return types. You know, if we're just taking state, we're not providing the value in the callback. Just give me, a function that can call immediately and just return the void. Otherwise, if you are providing the value in this reducer callback, then please give it to me in my callback function as well, right? And then I'll provide the subscription. So basically, those would be two different types. And then, of course, this is called function overloads. And then I need to implement the one that basically takes both of those cases. And here I'm just saying, hey, question mark. And here I'm doing the subscription because subscription overrides the void, no problem. So I was doing it that way, and I thought it would be all awesome and all working. However, as you can see here, updater, the state was any. How come it's any, right? It should at least be type. I understand I didn't provide the value v because then it just infers it, and at this point it kind of correctly infers it as any because, well, it's any. But the state I provide, why state is any, right? Later on, I discovered the TypeScript has this kind of interesting work here. Just have it here. So when I declare a function, right, and I say I want to have an argument of a type string, and I'm not passing the argument to this foo, right, it will complain. It says, hey, I expected one argument, but I got 0. All right, great. Now, I'm describing a function, the foo taker, that takes a foo, a callback, right? And foo is basically the same thing, right? I'm expecting the argument of a type string, and I want you to return me a string, for example, here. Right now, I can call this without any problem, and the TypeScript won't complain that I'm not passing a here. As long as I fulfill my return type, it's not complaining at all. And to be honest, for me, that took me by surprise. And every time I do something interesting with TypeScript, I learn a ton of new things. And every time that I think I know quite a lot, I learned something new completely. And this was no different. So this is one of those cases. So I was playing around with it. I don't need this. This collapse. Yes, this will collapse. So to play around with this newfound things, I also use TypeScript Playground, and I'm trying to simulate what's happening, right? And I was trying to do all kinds of stuff. And this is what you could probably see all my experiments here. They're all commented. I was extracting, analyzing, and I've spent a good chunk of my day on this, but I wanted to get it precisely right. Basically, right now, in this case, even setState. setState works, yes. So if I do the updater here, right? And now it doesn't like the title here. State would be, okay, so we got this right. Okay, good, good, good. So I don't want to basically type this one. Right now it's any. And I wanted to know the type correctly. So what I figured out is when the value is not passed here, this value is not passed, which could be actually taking this one as well. So when the value v is not passed in the callback, it'll actually get the value of unknown. And obviously here I'm trying it out. See, I'm calling the state. You can see this, right? The value, I don't know if you can see it. There you go. That's a little blurry. Yeah, so the value gets the unknown type when I'm not passing the value. So instead of having a few function overrides because it wasn't working anyway because it was hitting the first one, I decided to change the type and actually just type it with the state and value. But what I do next is interesting, is this one, and which is actually this one. So return type, how, because I still wanted to do a different return types based on, do I have this value or not, right? If I don't have this value, I just want to, I don't want you to be able to pass anything into this function callback. I want it to be empty and return void. However, if I do have something in the value, I want to, I want to force you to provide something to me. And basically, I write like almost those mini tests for myself here as well, right? I have like updater, and I try passing different things, and I want to be able to pass something that doesn't even belong to state and all of this. And I also check the types here, right? Okay, this is correct, right? This is, should be returning, empty function callback. And this B, because I have the value passed into, I want to make sure that it returns, the proper types, and it expects the proper things and a subscription. And then, and I write all of these for myself, right? For example, a state should work. It should not be any. All right, that's great. State works. And now the second one, right? I don't want to type this one. I know what the first one is. It should be the state type. I don't want to even type it. And I don't want it to be any. And this is exactly what it happens. Look at this one. So updater. It knows, it's very easy to disappear, that my state is a type of state. So this, I don't want any, I want it to know. And I don't want to type it because I'm lazy, and I know we should know about this. Value, yes, okay. I actually tried to, I've spent probably another good few hours. I wanted to go even further. If I wasn't providing the value type here like this, here I'm providing, but if I wasn't providing the value type like this, which is good, oops. Here, if I spent a good chunk of time to do this. If I wasn't providing this, I wanted, you see right now it gets to unknown type, but I really wanted to default to the partial of state. Why I wanted to do this is because it's very frequently that I notice we do things like this, right? The title, and I'm just basically putting it as one of the properties. So I was thinking, okay, if I don't want to type this one, I want to default to the partial state. I have a state and I'll have a partial state, and then it'll figure out that it's title and it'll work. That was not possible after all of many attempts. That's not possible today with TypeScript. Basically because of the unknown, it gets into a lot of things. I needed to infer it being unknown, but I couldn't set a default value as well, because if I was setting the default value like I was trying to do here, for example, partial of t, right, default, now it no longer would infer that it's unknown. It'll always fall back to this partial. Yeah, so that's not what I wanted to do. And I wanted to know if it was provided or not, right? And if it was not provided and it has a default value of partial unknown, it was already still partial of state. It was still partial of state already. So that wasn't basically the thing that I wanted. That's how I do all those expect error, and try to fiddle with things. And basically, you see that everywhere, for example, here I'm declaring the value of partial state, and I'm just passing the string, right? I expect the error here. This should be fine. I expect the error when I expect the value here, right? My updater expects the value, but I'm calling with the empty. So I want to have an error in this case, or something like this as well. Or, if there's a mismatch in types here, say value of Boolean, and I'm passing something else, I want to have an error. So all of those interesting cases I want to catch. So here, this is now getting back to this return type. I say, if unknown extends this v, which means v has to be unknown, I cannot do v extends unknown, because anything extends unknown. I need to know unknown extends v. So then I would definitely know that it's unknown itself. And then I say, okay, in that case, give me the empty function. Don't pass any arguments to me. If you do pass the arguments, that would be an error, right? And I won't give you the subscription back as well. And otherwise, although I do return subscription in any case, I just don't want, because there's nothing to unsubscribe from, really, because it will be executed synchronously. So void is okay, kind of thing here. And here I would give you a subscription even if it's already completed or it's not. But basically, I'll give you a subscription back. So those were that was all the code, right? This is like 110 lines of code that we are basically sending for review for Tim or Brendan, who probably watched half of it, or I don't know if he's still with us. So he would know what to review or what to look at it. But this is just one part of it. The next part that we also send is, as I said in the beginning, are the tests. Any code that we send, we want to make sure that it's tested. And here I have a few nested describes. By the way, we just switched to Jest. So that was a little bit of interesting situations here. But what I wanted to, yeah, still here. Great. Great. So, okay. We have we're sending 110 lines of code with comments and stuff like that. Let's see how many tests we have, how many lines of tests we have. And this is just unit tests. This is not integration tests yet. This is just unit tests. So for 110 lines of code, I'm sending 419 lines of tests. I'm not going to talk about select because my first PR would only include the initialization and updater, because I do want to split it up in 3 or 4 PRs for easier review, because each one of them would come with, for example, so the select and effect. Select will have probably also around 100 lines of code, maybe less, between the component store and the extra operator that I'll show soon. Not soon. Probably that'll be part 2. And then effect will be part 3. And if I'll have time for part 4, it will be probably some of the integration tests that we'll do. But what I wanted to highlight, you love HPRs. Yes, those are amazing. They are like, I love them too. They just hang in there and just like you open it up. It's like, oh, that's awesome. That PR is there. I know it'll be 5 hours of my life in that PR. I'm so eager to spend that 5 hours reviewing the PR. Yes, no, that's not what we do. We want to go fast over it. All right, but making sure that we basically have 4 times the code for testing the code itself, right? We have like 100 lines of code, and we have 400 lines of tests. All right, and what are we basically testing here are initialization, updates, and cancellations, because we are returning the subscriber. So we're splitting it up in 3 things that are major themes here. So the component store, initialization, updating the state itself, and canceling the update observable. Okay, so let's start with the initialization because that'll be the easiest one, right? We can say that, okay, we can test it through constructor. And I'm using here library called RX Marbles from Nicholas Jameson. Kind of like it. It's very well maintained. It works with any library, and it was really awesome because I actually didn't realize when I started writing this test, I was using Jasmine because that's what we had before in NgRx. It was all Jasmine-based tests. And I never used Jest myself, actually. I'm comfortable with Jasmine tests. We use Jasmine tests within Google. We don't use Jest. We use Karma, and it works, and it works fine and fast and parallel and all of that. But apparently, externally, Jest is taking over. So, and then, yeah, here's Nicholas's library, RX Marbles. It was as easy as switching from Jasmine to Jest. All right, very easy. He has Mocha. He has all kinds of things covered. So that was awesome. Awesome. Okay. Now, so what I do, basically, I wrap it with marbles. And marbles give me those M things, and I can do expect and provide some of the marbles. I'm not going to go into the details of marble testing because it's a whole different story. But what I'm going to do here is I want to say that, okay, I can test initialization through constructor, right? So I have my initial state. I create my new component store with this state. Notice there's no test bad stuff, nothing, right? This is unit tests of a component store. Component store is a class. We can new the class. Yes. So test bad is for testing components or larger integration tests. Okay. So now we do expect the state, right? This is the state that gets exposed to be observable, right? And we say it emitted a hot observable with I being this initial state. Great, it works. Then we say, okay, so we can have 3 ways, right? How we can initialize the constructor. Oh, this stays initialized if initial state not provided. This is also important, right? So for example, a component store, I'll create component store, we don't do anything, and we subscribe to the state, it would be hot of and nothingness. So nothing is emitted. This is really important as well. And then we can initialize through this init state method, right? So we create the new component store, which is nothing. And then we have our init state that we do the past one. And we call it. And we make sure that, it emits us this hot observable of initial state. So we basically test through constructor, init state, and through setState as well. But the setState, we are passing the object, right? Not the callback, but the object, and we make sure it works. Okay, now the error cases, those are always fun. And for some reason, well, I know which reason, but they're very frequently overlooked. I think those are really important, especially if you're trying to write the code and you forgot to do something. You expect the errors to help you debug things, and if they're not there, it just gets really hard to do. So, as library author or any code author, I want to make sure that my error cases are obviously, hopefully nobody gets into them, but if one does, we want to make sure that they get the full information that they need. So here it's just, I want to make sure that it throws an error when setState with a function callback is called, right? So here we're calling it with that object, which is basically a shortcut to the init state. But if we pass it the callback object, even though we set the correct type here, right? So we set the whole thing, we get the error, right? So for example, what I do say, if I calling setState, first of all, that setState is an observable I expect to be hot observable that it will give me the error. This is the case where in the component store, we on the error we push error to the state subject. So any observables that are subscribing or even selecting will in future will be selecting from this component store. They'll all get the errors because it was not initialized. But so this is one thing, right? The subscribers would get this error, but they won't get it immediately. They'll get it only when the setState was called with this. So we wrap this call with expect callback, right? And we just do to throw an error component store has not been initialized. Okay, so we tested this as well. We also test throws an error when updater is called before initialization. So this is very similar to setState, but it's an updater. Correcting the code as we go. I know that state, well, it'll be because we didn't provide anything here, it'll be just object, and here values object doesn't matter, so it's kind of matching. But now I'm calling the updater. I also get the error thrown, and I'm also getting the error in the observable. And then the third error case is with the sync observable is passed. So of is a sync observable. I'm passing this off, and I'm naming things as well, right? And say synchronous observable. So I want to highlight what exactly I'm passing. So I create the component store with nothing, and I pass this updater. I pass this synchronous observable, and the whole thing will throw the errors immediately as well. And obviously, all the subscribers will get this error. Nice. Now, not all observables are synchronous. Actually, most of them are asynchronous. So we want to test that as well and see what happens in that case. So it's also, by the way, it's like a documentation, right? So now anybody can get, have a question like, okay, what if I have an observable that's asynchronous? What do I expect this component store to do? Well, here's almost the documentation, what you expect to do. So it does not throw an error when updater is called with a sync observable before initialization. However, it will close the subscription and will not update the state itself, and it will send the error in the state. So what does it all mean? Well, we have a synchronous observable will be a called observable. So when somebody subscribes to it, only then an emit value. And again, not immediately, but on a second tick of this interval. It's like a 10 milliseconds of pretend fake time. So 10 milliseconds later, it will emit this value into the updater. Okay. And here, okay, so what we expect again, we expect this error from the component store when we subscribe to it, but then the whole thing triggers it. And this is where interesting part is. So components store this updater, and we pass the asynchronous value, and it will not throw. Why would it not throw? Well, because it doesn't know, because when we call this updater and pass this observable in, it's an asynchronous observable. So we have no way to know when exactly it will fire. And in the component store, it will only fail when that observable finally emits something. And then we'll check if it's initialized. And only then, we'll know that it's bad and it'll fire. But this one, initialization error, it's already past this. It will set this, but we already, outside of this function call. This function call was already completed. So this is to avoid any of the surprises. However, all the subscribers for the state will still get their error. So they will know, but not immediately, by the way, unlike the previous ones, right? Previous ones were immediately getting the error. And this one has also a first tick nothing, because our called observable won't emit anything until the second tick. And then on the second tick, we'll get this error when it finally emits something asynchronously. So I find this a very good documentation of this. All right, so we have one more case now. What if this asynchronous observable emits, we subscribe to it immediately, right, with that data, right? But it won't emit until we get the initial state. And this is exactly what we're going to test. So we say it doesn't throw an error when a data is called with a sync observable so it's called before initialization, right? But that observable emits the value after initialization. So we call the updater with this observable before initialization, but that observable does not emit anything. It emits something only after component store was initialized. Okay, let's look at how this one works out. So again, we create the component store without any initial state. And we'll create a few constants, right? When the initial state happens, and then when the update happens, right? So those are just some objects that we prepare. And then I want to record all the values that go through state as well into an array. So the way I can do it is I can subscribe to the state, right? I mean, again, it's a lazy state at the moment, so it doesn't have anything, but I'll subscribe for any future values that I'll have. And I'll collect them all in the results array, which could be just an object or array of whatever. We don't really care here. Okay, so, and we create our asynchronous observable. And that asynchronous observable will be of update state value. However, we delay it. We delay it until component store emits something. So this observable will subscribe to it immediately here in our component store updater, right? But it won't throw anything. No errors here. And no errors in our component state as well, component store state as well. Because our asynchronous observable does not emit a single value until component store says, okay, I have some value in it. And the way, it means this was already initialized. So then I'll trigger the initialization itself, right, within its state. And then I expect my results to have those initial values and updated state. So that's that basically covers all the error cases and the initializations, three ways of doing it through our tests. And this is like almost half of our tests. Cool. So what other tests do we have? So, okay, we have initialization now covered and all the error cases that are related to initialization. Now let's try to make sure that things are actually updating the state. And the way we update the state, we don't care how it's initialized. So before each test, we'll just say, okay, ComponentStore initialized somehow. So it's already, we don't have to worry about that initialized errors. So I can say, okay, I can initialize with a setState and pass a specific value, right? So basically, I can reset. It's almost like resetting the state to the specific value. And obviously, I can verify that, right? I subscribe and I get that. I can set the value based on the previous value. So this is where we're passing the state and error function, right? And we're using the previous state. So for example, here I have updated true that I'm passing. And our state will have a hot observable that has the combined values. Okay, so once I subscribe to it. Awesome. And then we can do with updater. So now we covered the set state. It's gone. Now the other one is updater. Updater based on the previous and past value. Okay, we have updater. We're passing the value. It knows the state type, passing the value. Also, we subscribe, we push the values, and we can call updater multiple times, by the way, here. So we once and twice, and we'll get all of those results. So we have initial value, we have updating the first time, and the second time is something else. So we get all of them, which is awesome. And also here we verify that the latest subscriber gets a single value only. So that kind of validates that our replay of 1 is actually returning our latest value, for the late subscriber, whatever we call it. Okay. So now we pass the values imperatively here to our updater. So this was our updater. We imperatively passed a few values here, right? Those are objects. Now let's pass an observable. So with updater to value based on the previous state and the past observable. So again, we have our updater. I'll record all the state value changes now with the publish replay, and this is just some of the interesting things to make it hot and basically start recording immediately. And to the updater, I'll pass the observable that emits one value after a certain period of time, and then another value, and basically completes. And then because I was recording all those values, I didn't want to just use the array with a push here, because what's important for me is the timing as well. And what's interesting here, this recorded state, it has an initial state initially, right? Although updater does not emit initial state, right? Because we already have it in the store. And when I subscribe, I get that initial value. But then, whenever this observable emits the updated true or value updated, we get them, and it aggregates them, so it all works. And it stays hot, by the way, right? So yeah, so that's basically covers all the cases for the updater. Customization updater. And the last one is canceling the updater, right? Because we are returning the subscription. We want to make sure that it kind of works. And here I'm using, so this is initial state before each test would basically initialize the component store. So it has the initial state already. And here I want to make sure that by unsubscribing with a return subscriber, I will cancel updater. Okay, so let's try it. I'm using the fake schedulers here because I'm advancing time manually, and this is interesting. So I have my updater function, which would take observable. And I'm recording all the results. Now, this way I'm recording through the array, just pushing those values. Anything that comes through will get pushed to this one because I don't really care about the timing now. We've verified the timing works. This is where we test the subscription. We only care that those values are there or not there. All right, and then I have my observable. And my observable is the interval. Interval of 10 means it'll start emitting from like 0, 1, 2, 3 up until infinity. Basically, it emits every 10 milliseconds. But I'm only taking 10 here just in case. So in case my tests or my things go really wrong, I don't want to be taking infinitely. Although my tests will eventually fail with a timeout, but having an error where you have mismatched results is a lot better than saying your test just timed out for whatever reason. That's probably not the best test. So I'm taking 10 just in case, right? So I'm limiting this infinite interval. So I'm pushing this to subscription now, right? And I should be able to unsubscribe it. So the first thing I do, I advance for 40 fake milliseconds. And then unsubscribe. And this should capture the values from this interval from 0 to 1 to 2 to 3. All right. And let's check it. So advance 40 fake milliseconds. And then the subscription unsubscribe. And then I advance for more 20 fake milliseconds, just to make sure that, if this interval was emitting anything, if this subscription didn't work, I would get more data into my, results push, right? Because this observable of this interval would be emitting. Okay, so just in case, it's actually a test, right? I'm advancing it for 24 milliseconds. And now I have results that are collected because I'm subscribing to the entire state here. And let's see what the results are. And I want them to equal, well, initial state, and then there's 0, 1, 2, and 3. And that's basically it. I'm making sure that it's to equal. I'm making sure that 4 and 5 are not here, even though I advanced for 20 more milliseconds. All right, so that was an interesting one. But then one other interesting case, I'm returning subscription, but what if I have a few of observables that are pushing those values into the updater? Because right now we're just using one. What if I have another one for this same updater, for this exactly same updater? If I have two observables independently pushing values. Well, that means that if I unsubscribe, I want to unsubscribe from only one of them, right? The other one should continue to work. So this subscription unsubscribe should not kill all the observables. It just should kill a particular one, right? Because I'm calling this particular observable with this updater. And that's exactly what I have this second test case for. Cancels the correct one. So I have some updater. I have two, now same updater, but now two observables that I called with. This is the same as we had before, the interval that I just take 10 just in case. And I call this, the first one's A. So it'll be, I'll use the value here. So it'll be A0, A1, A2, A3, and so forth. And this one is, instead of interval will wait for 10 seconds. I'll shift this one a little bit. So timer will also emit a value from 0 to infinity in this case every 10 seconds, but it will delay the first emission by 15 seconds. All right, so now this one will be pushing B values, B0, B1, and so forth. So they are pushing at the same time with a little bit of offset. And just like in the previous test, I first advanced it for 40 seconds, and then I unsubscribed from one of them on the first one. And then I advanced for 30 more seconds just to collect the other results. And then I basically kill the whole thing. But this one just takes 10, so it will end anyway. But because I advanced for only 30 seconds, this is where the results that I check actually. So I'm checking, okay, so initialize, great. Then they both emitting A and B emitting second value, A and B emitting. So each one is emitting and each one is basically updating the value. A and B for 3. And then because we're unsubscribed from A, now only B values are coming in. So we have B4, B5. So second observable continues to emit. And that's pretty much it for these tests. I think those tests are fairly thorough. I think they cover most of the code. Thinking about it right now, maybe I could have covered one more if I have my class at another store extending this store and I throw the error. The error should not be, what was my errors? The error should not be component store has not been initialized, but that other store that extended it, right? Because we want to really highlight where the error is. So this is one of the other tests that we could have done. It's okay. I think it's okay. So we have that. We have a code. We have a test for it. And one more last missing piece here is the documentation. Let's see. So we keep our documentation in projects, NgRx.io, content, and this is the guide itself. So there was already entry for ComponentStore, which was just indexed and there's nothing in there. There was just like a placeholder, just so we know stuff needs to go there. So this one I already adjusted a little bit. Basically, it's in Markdown files, right? I try to describe a little bit what ComponentStore is. I mean, this will definitely need to have a second or third round to actually add the documentation and dedicate some time to focus on that by itself. But I still wanted to have something there as I introduce things. So for example, right now we introduced the lazy initialization and we introduced how we can set the values. So introduction of this we'll do later. Key concept. This is some of the key concepts for the entire component store. Installation will show a little bit later. And then that's the first thing we do is how we initialize, and we can do it through different things and in the first example. So it's definitely not the final documentation, but it already has something, and I think it's okay if it's enough basically to accompany this PR that we have. Okay. So let me see what we have here. So I have a little bit more changes here. And let's see if I'll have time to go over them today at all. Probably not. Brandon, are you still there? So one of the things is, as I mentioned recently, is we moved from Jasmine to Jest, but we also have Blaze that is running our builds, and so builds our all of the packages. Oh, Brandon's still here. Yeah. So we have still Blaze that builds things, right? And then we deploy those builds. I think only Brendan right now deploys things. It's basically one of his expertise. Most of the time, Brendan merges things as well and builds them. So it's better to have a single person in control of that with full understanding. Although others should know about it, just to make sure that it has some clear responsibilities. Brandon took it upon himself. It's awesome that he does it. Thank you, Brendan. So yeah, merges and builds and deploys. That's what Brendan also does. And so, but now tests. So builds we still use Bazel, but tests we used to do Bazel, and now we do with Jasmine and stuff. We now do basically Jest. Bazel doesn't care which tools underneath it. Yeah, the steps are documented also. Yeah, thank you, Brendan. Bazel doesn't care. Bazel is just a universal tool. I mean, the entire Google is built with this through all kind of languages and everything else. It just, will figure out the dependencies through those build files, basically. And even the package, right? We have a library, TypeScript library. We say what the sources are. It packages it. For example, TS library actually is responsible for compiling them into JavaScript and all that stuff. So, and then we can package things and basically ship it. For tests, throughout our code base, we currently are using Jasmine, Jasmine tests. So we basically have our tools and where all our sort of rules are defined. I won't go too much into details because this is a lot to unpack probably, but we have our libraries and those are basically just some rules that go over things. And those are we were using Jasmine node tests that add additional some dependencies, and yeah, those rules create some sandboxes for itself. So it's just like the code is clean and stuff like that. So I wanted to add the Jest test as well. So we have a Jasmine node test, and I wanted to add the Jest test as well. And there were a few ways to do it. Jest tests themselves do not provide, obviously, the build thingy. So we can basically do the Jest CLI, and then Blaze will create a wrap around it. However, Jest CLI can take both JavaScript files and TypeScript files. It tries to be responsible for those, and they can compile them back into JavaScript and basically use the TypeScript compiler and orchestrate things on its own. However, we also have Blaze that does the compilation from TypeScript to JavaScript, and it creates the DTS file, the definition file, and I can also create some JavaScript sources as well. And this is basically how it checks what's changed and stuff like that. So when you rerun it, can either use the cached versions or rebuild it again. it can be really, really smart. So it could be, saving a lot of time when you have a large project under build. I'm not 100% sure Blaze actually makes a lot of sense for our size of a library. I mean, it's fairly small. We don't have a lot of build files, so those are like build nodes that look for each other and test. But I'm like, okay, we were using it at some point, so let's create, um, you know, um, a jest rule as well. And then I was looking into it. Well, Jasmine node test was already taking the compiled, basically TypeScript. So it was already JavaScript things that it was going over. Uh, I wanted to provide the same thing for Jest, right? Because if those do not change, then we don't trigger the Jest test itself, right? So if you didn't touch those files, it shouldn't rerun. So there are basically two ways to do it. Should I delegate the compilation to Jest itself, which is less preferred in the Blaze world, or should I just provide some already compiled outputs to the Jest and let it do the things? I initially decided to do it the more correct way, although it really doesn't matter at this point, because we don't operate on a ton of things. So I went with that way, and it needed a few interesting moments here. I needed already to get the sources and all that. And then I went also and created a TypeScript Jest test, the one that takes the TypeScript and TypeScript files. And I mean, it works almost exactly the same, a little bit less fiddling with things. They still unable to run Angular, the test that involves some of the Angular testbed, where testbed is involved. I haven't quite figured out why that's the problem yet. I'm pretty sure it's one of these, the setups, but even those, I made sure I put some logs throughout, covered it, and things were initialized, so it's still a mystery. So at this point, it was like, okay, should I touch those build for the test, for the ComponentStore test at all or not, right? I have basically two versions of it, just the Jest test, which was very similar to how Node was taking this, right? It was taking this compiled files already as a dependency here. So this was the Jest thing I first created. And then, TS Jest, I need to provide the entire sources and all the dependencies myself here, and that could just get rid of this test library altogether because it doesn't do anything at this point. Or I can just get rid of the Jasmine node, because Jasmine won't be able to run my spec file now, because it has some of the Jest specific things. For example, advancing that time that I had, like this advance thing. That's exactly here, by the way, the comparison, where I already changed it, because I was using the Jasmine clock for this, and I'm like, hey, great, because when I do development, I was using Blaze for running the tests. It's fairly fast, and then I'm like, oh, awesome. Now I'll run all unit tests, and boom, it says, oh, I don't know what the Jasmine clock is. I'm like, okay, yes, that's because we changed to Jest recently. Anyhow, so now we have a part of the code in our test that is dependent on which test library we use. And since we decided to go with Jest, I either have to delete this Jasmine node altogether and let Bazel not even know that I have these tests. It means that if I try to run the Bazel test on the entire thing, it will miss this test. Or should I use the TypeScript Jest test only which would work for now until I start using the testbed as well, because it won't work with testbed yet. So, but that's also won't come. I'll probably remove the Jasmine here at all, but that won't come as part of this PR and all of this, because it's kind of unrelated. So I'll have to split it into one more PR with tooling changes, basically. Yeah. One more thing before, it's very important. Before sending the PRs, it's very important to do, that's by the way, that's the test I was running. It runs the spec. It's a little bit longer, but yeah, all our tests pass, which is fantastic. I was just running the component store, so we have 15 tests. All right, the important part was git pull upstream master. So you'd always, before you push the PR, you'd always want to fetch the latest code from the library that you're trying to push changes to, and rebase on that. Make sure it's fine. Also, for the initial commit, it's most of the time it is recommended to squash it into a single commit. If you really have few distinct things there in your commits that you want to highlight, or leave it to, it will be squashed anyway. So, but again, most of the time, if, for example, I look at the PR, I don't look at the individual commits. I'm looking at all the files changes, and I'm trying to read through that, right? And the comments that are provided. So PRs is not for design discussions. PRs is for already, for minor things. Do we did this? Do we add the test for this? Or I think, by the way, this could be done a little bit differently, or hey, kind of best practice is to avoid some of the things. So those kind of things, they are not for design discussions, basically. Like very micro design decisions could be adjusted, but mostly those should be discussed ahead of time in the design docs. Yes, the test. Yeah, Brendan says test tools, test bootstrap, no test. Yes, I see this, but these ones are with Jasmine, right? I don't know if that would work with Jest as well. I don't know. I saw this one, and I saw this one was basically Jasmine node itself was pushing this this thing here. Maybe that will fix my TS my Jest TS things. Awesome. All right, so we've been up for almost 2 hours. I didn't write much today. I talked a lot. Yes, for the test bed setup. That's right. I'll try it. I'll see if that works, and then it'll be even better. So yeah, spent 2 hours talking. I didn't write almost a single line of code today during this discussion. Well, there's a little bit of adjustments and some of the comments and stuff. Hopefully they'll be useful. The next part 2, I would definitely be writing things. It would be probably more like 2 to 3 hours of stuff, depending how fast I'll write the test. But I think it was good. thing was good. Let me know if if you have any questions or any suggestions how we can proceed with part 2, because what I foresee part 2 and 3 and maybe 4 as well on this. So hopefully if we do it once, twice a week, we should be done through the entire component store, so you can play with it within 2 weeks or 3 weeks. Awesome. All right. So it's 11:30 my time here. I'm sure it's already late everywhere else. Thanks, Brendan, for basically hanging out with me here, and one more person there. That's still here. All right. Thank you. Have a good night.